All right, thank you everyone for attending this virtual open house. I'd like to give a very brief summary introduction of my research. So I work in the intersection of machine learning and image analysis. And you might ask, why this area? First of all, images are ubiquitous in our lives these days. So there are so many sources producing a continuous stream of images, anywhere from your handheld phones and cameras to microscopes and healthcare devices that are generating a continuous stream of images which are just begging to be analyzed. And there's not enough human power, human time on Earth to analyze all of these images. And this is where our machine learning and image analysis algorithms can come in and help. So the research in my lab has two things. One is we try to make it grounded in applications. These can range anywhere from healthcare to security, and I'll give an example in a second. Second, we are trying to innovate in the space of machine learning and image analysis algorithms. So applications and innovation is what drives our interest in this area. All right, so I just want to highlight one example application to give a little bit of more context to what I'm saying. So we are collaborating with radiologists here at the University of Utah. And what we want to do is we want to use deep learning for screening for diseases. So you might know that radiologists are very time pressed. These days with COVID even more so, but even in normal circumstances, they can only spend a few minutes looking at a chest x-ray that comes before them. And they're going to look for evidence of things that the referring physician asked for this specific patient. For instance, they might have asked to evaluate, does this patient have pneumonia? So they're not going to spend hours looking at the image trying to figure out what every possible disease evidence there is in there. So this is where machine learning can help. We can aid radiologists, we can augment their reports, and we can automatically screen for diseases. So as an example, we chose chronic obstructive pulmonary disease, COPD. And typically COPD is diagnosed using something called pulmonary function tests, not chest x-rays. So a patient comes in, there's this device they blow into, they exhale, and you're measuring their lung function, right? So we want to ask the question, can we screen for this? Can we predict PFT exams from chest x-rays? So what we did is at our University of Utah hospital here, we went back and looked at all patients, gathered the data for all patients who had both of these exams within a certain time frame of each other, say a few months, chest x-rays and PFT exams. Then we take a convolutional neural network, which is a state-of-the-art method in image analysis and machine learning these days, and we train it to take x-rays as input and predict the pulmonary function test values. In this way, now when we have new x-rays coming in, we can predict pulmonary function test values, even though that's not the primary interest for that patient. And we can see, according to the criteria for pulmonary function tests, does this patient fall into a risk group, and should that be further addressed? Now, that's the application side, but from the algorithm side, we're interested in kind of things, for instance, asking the question, the machine learning model, convolutional neural network in this case, made a certain prediction, but why is it making it, right? So don't just treat it as a black box, but can we build new models which actually, along with their predictions, also give you an explanation, an interpretation of why they made that prediction. Another thing we're interested in is to find, for instance, alternative ways to supervise the training of these models. The success of these models, to a large extent, depend on large amounts of data, and not just data, but manually curated data, labeled data. So imagine having hundreds of thousands of x-rays and then having each of them labeled as this x-ray has COPD or not, then we can train a very successful model. But getting data, labeling data in this way is not feasible, right? So radiologists don't have time to label hundreds of thousands of images for us. So we want to be creative here, and what we proposed to NIH to do, and we got funded for this, for instance, is to use the existing workflow of radiologists and somehow tap into this in an unintrusive way to gather the supervision data we need. So what we do is, they're already dictating into a microphone their reports. So we just added eye tracking device on their screen, and we're tracking where they are looking at as they are dictating. then we can correlate what they're saying with where they're looking at. And this, we believe, is going to give us a great way of actually training these models without additional data collection. Okay, so that is my brief summary. If you're interested, we're always evaluating and looking for excellent students. The work in our lab depends mostly on programming skills, computer-based experimentation, and also definitely math skills. So if you enjoy those areas, you might be a good candidate. And we have excellent computational resources to carry out this research in our lab. So if you're interested, feel free to drop me an email and we'll discuss. Thank you.